So far in this lesson, we've seen that a class can contain instance variables that represent the attributes of an object, methods for manipulating data within the class, and also properties as well for manipulating instance variable values either to get them or to set them. In this last version of the gradebook for this lesson, we're going to introduce another key component of a class definition, which is the concept called a constructor. Now, a constructor is a special method of a class that's used to help you initialize an object as it's created. So the object right from the start contains valid data. So for our gradebook class, what we've done for this new version of the example, first of all, we've switched to an auto-implemented property named course name, as I showed you towards the end of the last example. And again, it's a string property called course name with a capital C, and we're simply saying use the default get and set accessors. So the get accessor simply returns the data stored in the instance variable behind the scenes of this property, and the set accessor sets that instance variable's value. And again, the auto-implemented property creates that instance variable for you as a private piece of data that's hidden from you in this class. Now, we also have our display message method, and again, it is simply displaying welcome to the gradebook 4, followed by a new line character and a placeholder for whatever the course name value is. And the key new feature here is this gradebook constructor. Now, in all of our prior gradebook examples, when we created a new gradebook object, we always followed the word gradebook with an empty set of parentheses. And that is actually a special constructor that's known as the default constructor for the class. The default constructor receives no parameters and simply performs default initialization on all of the instance variables of the class. In the case of a reference type instance variable, that would mean that the variable is set to null by default. And in the case of a value type reference variable, it would be set to the default value for that type. So for example, all of the numeric types like integers and doubles are going to be set to 0, a Boolean would be set to false, etc. So the nice thing about a constructor is it gives you a way to provide data to the object of the class as you create it. So what we're going to do in this example is take advantage of the constructor to create a couple of different gradebook objects and give them their course names as we create those objects. Now, the gradebook constructor, and any constructor for that matter, has to have the same name as its class. So you'll notice that the constructor name gradebook is precisely the same as the class name. You declare most of your constructors public because generally you want some other class to be able to use this constructor to initialize the new object that's being created. If it were a private method of the class, a private constructor, then we would only be able to use it within the class itself. And you might say, well, that doesn't seem necessary, but there are cases where private constructors are handy. For example, one of the things you'll learn about when you get more into object-oriented programming is the concept of design patterns, and one of the popular design patterns is called the singleton design pattern, in which you have a class for which you only ever want to create one object of that class during the program's lifetime. And there's a way to use a private constructor and a static member function of a class to help implement the singleton design pattern. So it has to have the same exact name as the class. It does not specify a return type. It's not allowed to specify a return type. And the parameter list is like the parameter list of any other function. In this case, the parameter list says that the gradebook constructor expects to receive a string that is called name, and in the body of this constructor, we're simply assigning that parameter value to the course name property, which in turn will use the set accessor of the course name property to store that value. So let's see how we actually invoke the gradebook constructor. So here we have a simple gradebook test class, and in main we're creating two separate variables of class gradebook, one called gradebook1 and one called gradebook2. For the first one, we're creating a new gradebook, and I've broken this across lines because I ran out of space horizontally for book publishing purposes. I'm creating a new gradebook in which the parentheses contain the string value CS101 Introduction to C# Programming, and I'm creating a second new gradebook in which I would like to pass to the constructor the string CS102 Data Structures in C#. Every time you say new to create an object of a given class, that class's constructor gets called. And the decision on which constructor to call depends on the arguments that you pass into the constructor via the parentheses that follow the constructor name. You can have overloaded constructors, that is, many different constructors for the same class, as long as their parameter lists are different either in the number of arguments, the types of those arguments, or possibly, if you have the same number and same types, the order of the arguments as well. So in this case, I'm saying I want a new gradebook and I want to initialize it with the string CS101 Introduction to C# Programming, and in the second case I have a different string to initialize that object. Now, one thing I should point out is that once you define a constructor that takes arguments, the compiler no longer provides a free default constructor for you. So in any class that does not define a constructor, you get a default constructor that takes no parameters for free from the compiler. In any class that does define at least one hard-coded constructor, like lines 13 through 16 here, the compiler will not provide a constructor that takes no arguments. So going back over to main here, if I were to try to create a third gradebook, let's call it gradebook 3, and assign it a new gradebook and create this gradebook the way we did in the earlier examples with empty parentheses, then I wind up with an error message, the red squiggly line there, saying that gradebook does not contain a constructor that takes 0 arguments. So now we've actually added a requirement to our class. The requirement is, from the moment we create a gradebook, we must supply the course name as an argument to the gradebook constructor. So let me go ahead and get rid of that. And of course, after we've created our 2 gradebooks, we wanted to prove to you that we indeed have 2 of them and that they each have their own course names. So at lines 18 and 19 here, we display lines of text. Gradebook 1 course name is, and we have a placeholder for the result of this property accessor. Gradebook1.courseName says go to the Gradebook1 object in memory and return its course name. And similarly, down here at line 21, this one is saying go to the Gradebook2 object in memory and return its course name. So let me go ahead and set a breakpoint here for a moment, and let's run to this point in the program. And what we're going to see as this comes up and running is that now that we've passed through these 2 statements that create the gradebooks, I can hover the mouse over a given gradebook variable in the IDE, and it will show me which gradebook variable it is, and in that tooltip I can expand it and see that the course name for gradebook 1 is CS101 Introduction to C# Programming. Similarly, if I hover over gradebook 2 now and expand that, we can see that it has its own separate value for the course name, thus emphasizing the fact that when you have instance variables in a class, every object has its own copy of those instance variables. And remember, the course name auto-implemented property creates a private instance variable in which we are storing this string information for this example. So also down here in the debugger's locals window, we can see that same information. And the nice thing about doing it here is that you can clearly see 2 separate objects, the one that gradebook 1 refers to and the one that gradebook 2 refers to. We can see that the type of each of those variables is indeed gradebook, and we can see the course name property value in each case as well. Now, there may be one other thing you're noticing that's a little bit different here from the example in which we introduced an instance variable to you. Here you're not seeing the instance variable showing up in the debugger that is created for us by the auto-implemented property course name. When you have a hard-coded instance variable, it will show up here in the debugger. When you only have an auto-implemented property, it does not also show you that instance variable behind the scenes. So let me go ahead and stop the debugger here for a moment, and let's just run this straight through so that we can see that indeed Gradebook 1 has the course name CS 101 Introduction to C# Programming, and Gradebook 2 has the course name CS 102 Data Structures in C#.